Hi, my name's Dan, and this video is the first in a short series of videos that I'm doing about multiplexers, which are a particular kind of component in digital electronics. And to contextualize that, actually this short series of videos is part of a much larger series of videos in which I'm uh, slowly developing um, a simulated but fully working 4-bit CPU. So I'm using this software here, Digital Works, which is simulation software for digital electronics. And a roadmap of where I'm going in this CPU development is down in the description underneath the video, and also a link to this Digital Works software is there as well. And in case I didn't say, the aim is to develop a simple 4-bit CPU from scratch from the logic gates that make it up, and to build macros on macros until we have a functioning CPU, which is quite an ambitious aim. So it's going to be quite a few videos. This short series of videos, then, is about, as I said, about multiplexers. So first of all, let's explain what that is. A couple of series ago, if you've been following along in the larger scheme of things, I did decoders, and that allows you to put a binary number in and to choose a number of one of a number of discrete outputs. And when that was combined with enable, actually, one thing that I didn't highlight at that point is that this actually gives you the ability to route a signal. And so, say you've got a 4-bit binary number, if you used 4 decoders, one for each bit, and if you wanted to send to one of 16 different destinations, then you'd need a 4-bit decoder for each. So if you used 4-bit decoders with enable, you'll be able to create a routing system where you can route that 4-bit number to one of 16 destinations. What multiplexing does is effectively the opposite, which allows you to choose from a number of input binary numbers and output one of them that's been chosen. So we're going to start with the simplest level of this, which is a 1-bit multiplexer, and this is a 1-bit two-way. So this means there are a choice of two sources that you can have. There's only ever one destination on a multiplex. And so there will be the discrete inputs, so 2 of those, and there will be a choice number coming in, which is just a 1-bit binary number to choose which of the 2 inputs is going to be routed to the output. I hope that's fairly clear, or you understand what's going on. These things are hugely useful in the creation of digital electronics of all kinds, but definitely useful in computing. So what I'm gonna am I gonna do it with inputs and or go straight to tags? I'm gonna go straight to tags. So I'm gonna set up with the two. These are the 2 signal inputs. I'm going to call them A1 and A0. Up to 10 points. A1 and A0. And then I'm going to have an output. Not wiring up yet. Output. And then the control will be the thing that actually chooses which of the inputs goes to the output. So this is I'm going to call it control. There we go. And if the control input is 0, then A0 goes to the output. If the control input is 1, then A1 input goes to the output. Okay. So the first thing that happens is that actually we want to take the control input and turn it into a couple of discrete lines. This is effectively the same as doing a decoder, but a 1-bit decoder is really straightforward. So we're just going to use the ability to do that here. So I'm going to have 2 lines, and then the control then effectively is used as an enable to enable one of the 2 inputs that we've got. And as I've discussed before, enable is almost always an AND choice. So we're going to have a couple of AND gates. So let's wire up that one to our A1 input, that one to our A0 input. And one of these lines is going to choose A1. So when we've got a choice like this with a straight line and a line that's been inverted, then the one that will connect without the inverter is the one that will be high when the input is 1. And the one with the inverter is the one that will be high when the input is 0. So in order to choose the input 0, we want to use that one. Could tidy this up a little bit, but it's not too bad. And then we want to take off from that one there to connect to that one. Okay. So at this point, we'll have one of these 2 enabled, depending on the control input. And we want to make sure whatever input is enabled gets routed to the output, and that is an all. So if either of these is happening, then it will come to our output. I'm just going to do those as angled lines there. Look reasonable. And our output. Okay. That's the basic principles of any kind of multiplexer. And to increase the complexity of a multiplexer, you can have a larger number of inputs, and then you can also duplicate this to give yourself more than 1 bit. But essentially what you've got is your control will come into a binary decoder. You'll have several discrete inputs. The binary decoder outputs will go to AND gates, which are then linked up to your discrete inputs. And all of your AND gates will then be filtered into either 1 or more OR gates, depending on how many you need to connect together to give you your output. So we're going to turn this into a macro and then put it in a circuit and demonstrate it. And we've got stuff here that's left over from previous. Actually, I'm going to junk all that and basically start again with this. So I'm going to put my inputs at the top and the control on the side and the output at the bottom. And let's do a nice box first. Maybe I could have left the box because the boxes are a pain. Come on, get that close. Is that lined up? It's got a little bit of an extra bit on it there, but I'm not that bothered about that, really, to be honest. Excuse me. And shortcut for text for multiplexer is MUX. And this is 2-way, 1 bit. And we're going to stick on our inputs at the top. So O1, O0. Going to have our output at the bottom. And we're going to put control down here on the side. Okay, switch to text. Change that down to 7 points for labeling inputs and outputs. A1. A2. control, and output. And I put the output way over there by accident. I'll move that control down a little bit. There we are, not a lot of inputs and outputs on a 2-way 1-bit multiplexer. Let's do the wiring up. So there's the control, so that's going to go to there. And that's A1. Ah, come on, select it. A1. A0. I've labelled that wrong. I did A1, A2. That should be A0. And finally, outputs. So at this level, this is quite a simple circuit. I've only got 3 gates, 4 gates involved in this. And let's save as. So what did I call it? MUX. And it's 2-way 1-bit. There we go. Let's make a circuit to test this. A new circuit, MUX 2-way 1-bit. And we're going to need some interactive inputs and an interactive output. Just the one. La, la, la. Wiring, wiring, wiring. Here we go. So, just to reiterate how this should be working, we've got 2 inputs, and control should choose which of those inputs is going to the output. Let's kind of run it in simulator. At the moment, control says that we're using the 0 input, and so I put that high. Then there's a slight delay in the simulation, but then the output goes up. And if we make changes to A1, it's not doing the output. And if our control goes high, it should then pay no attention to A0, but A1 is routed to the output. There we go. That's the very simplest kind of multiplexer that you can have. 2-way, so it's got a choice of 2 inputs, and it's 1 bit. And that's it from me for now.